In this video, I'll show you a beginner process for solving the last layer of the Megaminx. Okay, so now that we've solved our F2L and our S2L on our Megaminx, it's time to solve the last layer of the Megaminx. And this can be a little bit more tricky than solving the last layer on a 3x3 because we have 5 edge pieces and 5 corner pieces to deal with. We're going to approach the last layer in 4 basic steps. So firstly, we're going to orient all of our edge pieces, then orient all of our corner pieces, permute our edge pieces, and then permute our corner pieces. So the first step is to orient all 5 of our last layer edge pieces. And there are 2 algorithms that you can use to do this. You will most likely already know both of these algorithms, so it's just a matter of applying them to the Megaminx. So the first algorithm is F, R, U, R prime, U prime, F prime, and doing that algorithm orients this edge and this edge here. So this front edge and this back right edge. So if we do F, R, U, R prime, U prime, F prime, now we have 5 edges oriented. If we need to orient 2 edges that are adjacent to one another, so that is here and here in the front left and front right positions, we can use the algorithm F, U, R, U prime, R prime, F prime. So performing that algorithm on the Megaminx changes the orientation of these 2 edges which are adjacent to one another. In addition to the cases where we have 2 edges misoriented, the 2 other alternative cases that we can have on our Megaminx are, firstly, if our edges are all oriented already once we get to the last layer, then we don't need to do anything. And secondly, we can have a situation where there are 4 edges misoriented. So that is, we only have 1 edge oriented on the last layer of our Megaminx. And we can tackle this in a number of different ways, and you can experiment and try things out for yourself. But one way we can do that, one way we can deal with this is just by using this, orienting this one and this one using our F, R, U, R prime, U prime, F prime algorithm, and then orient these 2 using F, U, R, U prime, R prime, F prime. So in the case where you have 1 edge oriented only, you'll need to use those algorithms a maximum of 2 times to orient the remaining 4 edges. So once we've oriented the 5 edges of our last layer, the second step in solving our last layer on the Megaminx is to orient all 5 of our corner pieces. So that is, make all of these 5 corner pieces have the grey sticker facing upwards. The easiest way to do this without learning any complicated or long algorithms is to use a simple 4-move algorithm over and over again, which cycles corner orientation, and I'll show you how to do that now. So the algorithm that you need to remember is R prime, D prime, R, D, and that might look like it messed up a bunch of things, which it did, but I'll show you how to use it shortly. Also note that when we're doing the Megaminx, D is kind of an ambiguous movement. In this situation, for this algorithm, we're using D to refer to this layer here, so the one directly beneath the right layer. So what we do is, to apply this algorithm, we take a misoriented corner and we put it into this top right position here. And what we do is do R prime, D prime, R, D, over and over again until this corner piece comes to this position and it's oriented. So here this corner piece is back in this position, but it's not oriented correctly. So we keep on applying that algorithm. And now we have this corner piece and it's correctly oriented up here. And what we do is, even though this is scrambled down here, we don't need to worry about it yet because it will resolve itself eventually. What we do is we rotate the top layer only, so hold the puzzle in at the same position, but just rotate the top layer so that another misoriented corner comes to this front right position. And then what we do is do the algorithm over and over again until the other corner is oriented. So that was corner orientation in a case where we needed to orient 2 corners. In this case, for example, we have 4 corners that we need to orient correctly. So it will take us a little bit longer and we'll need to use, I guess, more repetitions of that R prime, D prime, R, D move in order to orient these 4 corner pieces. So here what we would do, we start out, so if we had this one's already solved, so we don't need to deal with that one. Just do a U move. and start out by doing this one. So R prime, D prime, R, D, R prime, D prime, R, D. Now that one's oriented. And you will notice that sometimes you'll need to repeat it twice, and sometimes you'll need to repeat that R prime, D prime, R, D 4 times, depending on this orientation. So now we've done that. This one's oriented as well. We can do another U move, then do R prime, D prime, R, D, R prime, D prime, R, D to orient this one. Then do another U move and orient the last one. So obviously doing R prime, D prime, R, D over and over again is very inefficient, and I do suggest that you try and play around with some of your last layer corner orientation algorithms from the 3x3 on the Megaminx and see what sort of things you can discover to try and help make your last layer corner orientation a bit more efficient. So here, for example, we have a case where we need to orient these 3 corners in a clockwise direction, and this looks awfully similar to this case on a 3x3. Where we need to orient these 3 corners in a clockwise direction. So what we would do is do R, U, R prime, U, R, U2, R prime on a 3x3. We can do something similar on the Megaminx, and this is, again, something you can play around with, is we can do R, U, R prime, U, R, then U2 prime, R prime, and that orients 3 corners in a clockwise direction like this. So in a case where you have, maybe 0 corners oriented on your last layer, so none of the 5 corners are oriented, then you can try algorithms like this to see if you can orient a couple of the corners very quickly and easily before going into your long R prime, D prime, R, D, etc. moves. So after we've oriented all of our corners and all of our edges, the third step in solving the last layer of our Megaminx is to permute all of our edge pieces around this last layer. So that is completely solve all of our last layer edges. There are 3 basic cases for this that we're going to have a look at. So the first thing to do is to rotate your top layer around to try and solve as many edges as possible. And in most cases, you will be able to solve 2 edges. If you already have a Megaminx where all the last layer edges are already permuted, then you've skipped this step. But if you haven't skipped edge permutation, then you'll be able to align your top layer to a position where you can correctly solve 2 edges. So for example here, we've correctly solved this grey and orange edge and the grey and pink edge. So here we have a situation where we have the front edge permuted and the back right edge permuted. So they're kind of opposite one another. So they're not adjacent to one another. And the algorithm that we're going to use to help us permute all of our edges in this case is the T permutation. And you'll know this algorithm from the beginner's method or from PLL or from for look last layer on the 3x3. So it's not like we're going to be learning a new algorithm. We're just going to be applying it onto the Megaminx to help us solve edge permutation. This may be a little bit counterintuitive because when we're using the T permutation on the 3x3, we often do it to permute the corners, but here we're doing it to permute our edges. So essentially the T permutation will rotate these 3 edges in an anti-clockwise direction. So what we do is we hold our solved edge at the front position and the back right position, and then from here we'll either need to execute the T permutation once or twice to solve these 3 remaining edges. So like that, and notice that that didn't solve these last 3. So that was a case where we needed to do it twice. And now we've solved all of our last layer edges like that. So that was for the case where we have 2 edges permuted and they're opposite from one another. So that was, they weren't adjacent to one another and we needed to cycle 3 edges like that. So for that case, we use the T permutation algorithm and you'll need to execute it either once or twice. So another situation that you'll run into when trying to permute your edge pieces is when you try and align them and try and solve some edge pieces, and you get this situation where you have 2 edge pieces that are solved, but they are adjacent to one another. And in this situation, we'll need to use a slightly different algorithm. So this is the Rgb permutation, and you may already know this from 3x3 PLL. But if you don't know this, here is the J permutation. And effectively how we do this case is we hold the solved edges at the left position and the front position, and then we execute our Rgb permutation, and we'll either need to do this once or twice depending on how these other three edges are permuted. So holding these two solved ones at the left and the front, we can execute our Rgb permutation, which is R, U, R prime, F prime, R, U, R prime, U prime, R prime, F, R2, U prime, R prime, like that. And in this case, we had a situation where we only needed to execute that once, but sometimes, like I showed you with the T permutation beforehand, you might have a case where you've got these two edges solved adjacent to one another, and you'll need to execute the Rgb permutation twice to actually cycle these three edges correctly. So the last situation for edge permutation is if you're rotating the top layer all around and you literally can't find a rotation of the top layer such that two edges are permuted, and that's fine. And sometimes, this is a rare case, but sometimes you'll only ever be able to permute one edge at a time. You'll never be able to get two correctly permuted around the top layer. And in this situation, we simply apply either the J or the T permutation, and then we'll get one of the other cases. So let's just go for a T permutation, like this. And now we have a situation, here we actually have all of our last layer corners permuted, which is not ideal because we're not even trying for that. And looking around the cube, we have these two edges permuted. So what we can do is hold them in the left position here and do our J permutation algorithm. And that permutes these three edges over here. So after finishing the edge permutation on our Megaminx, it should look something like this, where all that's left to do is solve the last 5 corners of our Megaminx last layer. The good news is, to permute these corners, we won't really need to learn any long or complicated algorithms because we can do it with a process known as corner commutators, and I'll show you what this is now. So by using corner commutators, we're essentially able to take out one of your last layer corners and then replace them and solve them into their correct positions. So we'll start out our corner commutator process by looking at the corner in the front right position. So this is the grey, orange and light blue corner piece. If the corner in your front right position is already solved, then rotate your Megaminx such that an unsolved corner sits in this front right position. So after we've noted the colours on this corner, so this is grey, orange and light blue, what we're going to do is do R prime, D prime, R, like that. And that puts it over here. And then what we do is rotate the top layer to find its correct position, so to find where this corner belongs, and put that position up here. So that is, for this grey, orange and blue, light blue corner piece, we need to put it in between these light blue and orange edge pieces, so it belongs in this position. And then what we do after that is do R prime D R. And what that does is replaces this corner piece into this position. And now we're not done yet. We need to go on and solve the rest of our corner pieces. So after doing R prime D prime R to take out your first corner, and then a rotation of the top layer, and then R prime D R, we're going to do the same sorts of moves again, but apply them differently to solve a different corner. So after doing those moves, we now have this grey corner piece, our last layer corner piece, down in this position, and we need to find the position where it belongs. So this is the grey, light blue and light yellow, and it belongs in this position between the light blue and light yellow edges. So what we do is rotate the top layer so that this position comes to the front right here, and then again we go R prime D prime R, like that, and that puts this corner piece into this position. And you will notice these moves do mess up the bottom layer temporarily, but that's okay. So having done R prime D prime R to solve this corner piece, we actually took this other grey, light green and orange corner piece out of this top layer. So we need to find the position where this grey, light green and orange corner piece belongs, and it belongs in between the light green and the orange edges back here. So we do a rotation again of the top layer, and then to put it up into this position, we do our moves R prime D R again. So notice that when we started this corner commutator process, we used the moves R', D', then rotated the top layer and then did R', dr, so the reverse of those first three moves. And that's the process that you'll essentially be following to continue cycling all of your corners on this last layer. So you'll be doing R', D', a rotation of the top layer, then R', dr, then a rotation of the top layer. The number of times that you'll need to do this depends on the number of corners that you need to solve. So here we only have 2 more corners that we need to solve. This grey, pink and light green one is down here. So we move the top layer such that the light green and pink edges are here. So this one needs to go up into this position, and then we do our moves R', D', and then for our last corner piece, our last grey corner piece, it goes down here and it belongs in between the pink and light yellow edges up here. So we do R', D, R, like that to finish it. And now after solving all 5 of our corner pieces, our entire Megaminx will be solved. Because we're using R', D', R and then R', dr constantly throughout cycling our corner pieces, there are a couple of situations where you might be a little bit stuck or confused. So one example is this case. So I'm going to start out by taking out this grey, pink and light green corner piece with R', D', R, and then it belongs over here between the green and pink edges. So I rotated the top layer this direction, and then I'll do R', dr. Then this one is the grey, light yellow and pink, which belongs back here between these two, R', D', R. And now notice that we've done an odd number of these R', D', R moves. So we've done 3 of those. So our bottom layer will actually be scrambled, but we've solved these 2 and we have 2 more corners that need to be swapped. What we do now is just move one of these unsolved corners over to this front right position and then do R', D, R again. And that will restore the scrambled bottom layer as well as take out a corner piece from the top layer. So now we've got this grey, orange and light blue corner piece, which needs to go in between these 2. So rotate, insert it with R', D', R, and then our last corner piece, the grey, light green and orange, belongs here. So we go R', D, R, like that, and then finish off our Megaminx. So I hope these videos helped you solve your Megaminx. In the next video in this module, I have a full example solve using this method to help reinforce these techniques.